Okay, vectors. So previously we were studying about straight line. Straight line uh was a one-dimensional thing. Like a straight line is a one-dimensional curve. But when it comes to vector, we have more features. It tells us more. What exactly? So a vector tells us the direction. From where to where. A vector tells us from where to where. And also, how much do we have to travel from this point to this point? How much? So we call it a magnitude. So a vector tells us two things. From that points that we are going to consider are from where to where and how much do we have to travel in that particular direction. Okay. So as we are talking about these things, so a vector have two elements in it, direction and the magnitude. A vector quantity. There are scalar quantities as well. Scalar quantities only tell us the magnitude. Or should I say, they do not care about direction. Those are scalar quantities. For example, mass, speed, distance, etc. These are some examples of scalar quantities. Now, talking about vector quantity. So, force is a vector quantity. We have to know that in which direction I am applying the force and how much force am I applying. Displacement. What we care about all is from where to where I have reached and what is the straight line shortest distance between these 2 points. That's displacement. So we care about magnitude and direction as well. Velocity. Velocity is the speed with direction. Simple. Etc. These are vector quantities. These are scalar quantities. So a vector have two elements in it, the magnitude and the direction. Is this clear what a vector is? Yes or no?
Yes, sir.
Okay. So now let's understand a vector. So let us talk about a vector A. This is the representation of vector. This is how we are going to represent a vector. A vector have its magnitude and its direction. So this part is known as the unit vector of A. This is the magnitude of A vector. Okay, so let's understand using an example of our Cartesian system. X-axis, y-axis, and z-axis. Right? And z. Okay. Now, this is origin with which respect we talk about everything. So let's say if I have to move from 0 to 1 unit in x direction, like this is 1. If I have to move from origin to 1 in x direction, then I call it that I am moving in the direction of x, and that is I, because I'm moving unit distance, I cap. If I move in positive y direction to the +1, then I call it as z cap. If I have to move in z direction, that is this, call it as k cap. So if someone has to move in x direction, I cap is used as the unit vector, and in y direction, then z cap is used as unit vector, and if one has to move in z direction, then k cap is used. Okay, positive z here. So I cap, j cap, k cap are the unit vectors for x, y, z axis. If I have to move 2 units in x direction, so I'm going I cap and I have to move 2 units. So continuing, so this is 2 I cap. If I have to move 2 units in y direction, 2 units in y direction, so that's my b vector. Let me call this as a vector. So from here we derive the concept of position vectors. Let's copy our diagram. Let's copy. Position vectors. Okay, so this was origin, x-axis I cap, y-axis j cap, z-axis k cap. So simple concept is this: if I have to move to any point, it's, let's say its coordinate are A, B, and C. A coordinate in x, B coordinate in y, C coordinate in z. So if I have to find OP vector, I'm moving from O to P. O to P, from the origin to the P. So this OP vector is actually A minus 0, like the distance that I have to go in x, that is because origin's coordinate are 0, 0, 0. So A minus 0 I cap plus B minus 0 j cap plus C minus 0 k cap. So the OP position vector comes out as A I cap plus B j cap plus C k cap. So here OP vector is a position vector which is telling us the position and as well as the magnitude. How the magnitude? We will be able to find out the magnitude of any vector by using the formula that I'm going to write now. You must be remembering the distance formula from the rectangular Cartesian system that we have discussed. And we are yet to discuss the 3D. So in 3D, there is a distance formula between 2 points. That x1, if there are 2 points like point A, point B. Point A's coordinate are x1, y1, and z1. And B's coordinate are x2, y2, and z2. So if I have to find out the distance between A, B, the distance will be square root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So similarly, here the distance between O and the distance between the distance between O and the distance between P is the magnitude of our vector. So that's how we have written the magnitude of this position vector using the distance formula. Are there any questions?
No, sir.
So vector is giving us the magnitude and as well as the unit, the direction. Okay, give me a moment. So this is about a position vector. Now what about the unit? Like a vector must be having two things, the magnitude and the direction. This time it's not simple. Earlier we were discussing about 2 I cap. So the direction was simple. The I cap is the only direction. But this time we are also moving in X as well as in Y and as well as in Z. So the direction will be found out by simple. As we have talked earlier, that in any vector, if there is any vector, it includes its magnitude multiplied by its unit vector. So our unit vector will come out as the vector divided by its magnitude will give us the direction, will give us the unit vector, unit vector. Okay, so using the same concept, we'll find out the unit vector here as well. So OP unit vector will be the OP vector divided by OP vector's magnitude. So the OP vector is AI cap plus BJ cap plus CK cap divided by the magnitude, which is square root of A square plus B square plus C square. So this is the unit vector of OP vector. If we multiply OP unit vector and this, we'll get the vector, position vector. So is the concept of vector clear? What is the vector, what is unit vector, and what is magnitude? It's very important for you to understand. If you have any doubt, please ask. No doubts?
No, sir.
So I'm writing some vectors here. You have to explain me these vectors. Okay, one by one. Yarini, please tell me the first vector, what it is saying to me, like what is the magnitude of the vector and what is the direction in which the vector is telling us to go from where to where. Yarini. Okay, Guru Charan.
Sir, is it 2?
What is 2? You have to tell me two things, magnitude and the direction. You were right. Try.
Magnitude is 2, sir.
Okay, great. And direction? Tell me in the terms of X, Y, and Z. How much do I have to move in X or Y or Z? Right? You can try. There's no problem in giving wrong answer.
Sir, is it like in X, it needs to move 2 times? Like,
Ah, very good. Y in X only, not Y, not in Y?
is it because it's high and so,
Yes. Good try. Yeah, and good answer also, not just try. Yes. Second, Guru Charan.
Sir,
Yes, Guru Charan, please. Second, you have to tell that magnitude and the direction.
sir, it's -2.
What is -2?
The magnitude,
Is magnitude ever negative?
it's direction.
So what is the magnitude? Say it, no problem. What is magnitude of this vector? Let me tell you एक बार मैं वापस जाकर let me revise. If there is a vector A x I cap plus y j cap plus z k cap. Okay, so its magnitude will be square root of x square plus y square plus z square, and its unit vector will be simply a vector divided by the magnitude. So x I cap plus y j cap plus z k cap divided by square root of x square plus y square plus z square. Is there any difficulty in understanding this?
No, sir.
Now its vectors, let me call this as A vector. So its vector's magnitude is 2, its direction is I cap. If this is A vector, then its magnitude is 2. Its direction is minus of j cap. Minus j cap means we are going in minus y axis. Okay? If this is A vector, then now Guru Charan, please tell me what is its magnitude? What is its magnitude, Guru Charan? Hello, Guru Charan.
Yes, sir.
What is the magnitude of this vector?
5, sir.
Please maintain attention. What is the direction? Unit vector.
Okay.
Hmm. Okay. Means in z axis, positive z axis. If this is vector A, then what is its magnitude? Yarini. What is its magnitude, Yarini? What is the formula for finding out the magnitude?
Sir,
What is the formula? Don't speak, it's there in front of you.
sir, it's root of x square plus y square plus z square.
Yes. What is the coefficient of I cap here? X was the coefficient of I cap here, na? What is the coefficient of I cap here in the fourth? No?
We don't have
Hmm.
cap,
We
so
don't have I cap.
Yes, we don't have I cap. So we can consider its coefficient is 0. What is the coefficient of y j cap here? Come on, speak.
-2, sir.
-2, sir.
Yes. What is the coefficient of k cap?
5, sir.
5, sir.
Square root of x square plus y square plus z square, whole square root. And then it becomes 0 plus 4 plus 25. So its magnitude comes out as square root of 29. What is its unit vector now? Come on, tell me what is the formula for finding out the unit vector of A vector? How do we find A cap here? It is simple, yaar. Look here. B, divide the vector by its magnitude to find out the unit vector. What is the vector here? 5k cap minus 2j cap divided by root 29. So that's unit vector. Simple. That is the unit vector. Clear? Any doubts?
No, sir.
No. Great. So let's now move ahead. So now we have got to know that any vector have two things in it. The unit vector's purpose is to only tell us the direction. Only tell us the direction or depict the direction. Its only purpose is how much magnitude. From here we have got to know that we are going from where to where, and how much to move will be depicted by the magnitude. And we have discussed about how can we calculate the a cap and the magnitude. Magnitude is just the distance between those 2 points, right? Okay. So let's now talk about the operations between two vectors. Before that, let me take another example of position vector. So when we say any point, we always calculate that like the point from the reference of the origin, and that becomes our position vector. But if we are talking about 2 points, A and B, and the vector from A to B, then how do we find out this vector? Then B will also be having a vector from the origin, right? So let's consider A is having coordinate as x1, y1, and z1. B, x2, y2, and z2. So AB vector, how do we find out this? We know that for A, we are going from x1 to x2. So in I direction, for the x-axis, we have to move from x1 to x2. So we can write x1 minus x2 or x2 minus x. That's same. So if we are going from A to B, then we'll write the B vector first. X2 minus x1 I plus y2 minus y1 z cap. For the k cap, z2 minus z1 k cap. That is AB vector. What we have done for finding out AB vector, we have done actually, we have subtracted OB vector from OA vector. And from here comes the addition, the triangle law of vector addition. If I rewrite it, AB vector plus OA vector equals to OB vector. See, AB vector, OA vector plus AB vector equals to OP vector. This is the triangle law of vector addition. First, we have understand that if there are two vectors given, how do we find out the vectors between those 2 points? Simply just subtracting. If we are finding out the AB vector, so we'll subtract x2 minus x1. Now let's understand the triangle law of vector addition. Before moving ahead, are there any questions in understanding how do we have find it out this position vector?
No, sir.
So in triangle law of vector addition, it's simple. If there is a vector like this, then there is another vector connecting from the head. This is the head of the vector, na? There is another vector connecting from its head with a tail, and then there is another head. So to add two vectors, we have to fulfill this condition where tail and head are connecting. Now there's some vector, the resultant vector of the addition vector will join from the one of its tail and one of its head. So this is A vector, this is B vector, and this vector is not following the law. Like the direction is here, and then the direction is here. And there is a reverse direction. So this vector will be the addition vector. A vector plus B vector. Let me change the color so that you can notice. This is the A vector plus B vector. I repeat, you're going like this, then the vector defining the direction will be the addition vector. Okay, what if you don't have vectors in this condition? What if the vectors, there's one vector like this, and there's another vector connecting from its tail, and we need to add these two vectors. Okay, then what will we do? Here, the addition vector cannot connect two heads, because earlier we were talking about that these two vectors had to be connecting in such a manner, had to be connected in such a manner that the head is joining to the tail of the other vector. But it's not happening here. So what we do is that we relocate the vector hypothetically. We relocate the vector hypothetically. How do we do so? We'll take this B vector and we'll displace this vector here. And we'll connect its tail with the head. Let me make our diagrams little smaller. So we have displayed the B vector, displaced the B vector. Now the vector joining from here to here will be the addition vector. A plus B vector. Okay, as we have founded out the vector using the same triangle law, we have displaced the B vector. First, let's understand this once again. There was a vector connected by the vector head and tail. One vector's head is connected to the tail of other's vector. Then we connect the tail of the first vector and the head of the other vector in such a direction that is given, define the rotation already going on. That particular vector will be the addition vector. This is the triangle law of vector addition. Are there any questions? Difficulty in understanding this? Any questions?
No, sir.
This is known as the parallelogram law of vector addition. Okay. Any difficulty in understanding this? You have hypothetically moved this V vector. No? Any doubts?
No, sir.
Okay. Let's now discuss the properties of vector addition. First is that vector addition is commutative. A vector plus B vector. And now I'm not going to like draw the arrow. I'm representing A vector as A bar. Okay. It's the same. A vector plus B vector is equal to B vector plus A vector as well. So the vector addition is associative as well. If B vector plus C vector addition is getting further added to A, then it is equivalent with writing that A vector plus B vector addition is also adding to vector C. Let's say that B vector is this, C vector is this, and B plus C vector is this, and A vector is this. A vector is this. So A vector is adding to B plus C vector. Then it will be giving the resultant vector, na? So let me, it's not connected properly. So we have to displace the A vector. How do we displace? We can displace it by reversing. First, we have to reverse the vector's direction. So I'll simply do minus, we'll change the direction. And then we'll add. And what is written here, that the vector addition, after we have taken the vector addition of A and B, and then it is further getting added to C, that is equivalent to the left hand side. Any doubts?
No, sir.
Third property, simply that we can place vectors hypothetically for addition. Application is key. We have discussed in parallelogram law for vector addition. Now there are some different kinds of vectors. Let's discuss them one by one. They are not much important. First, is free vectors. Those vectors which are not related to any specific points are called free vectors. These vectors do not change due to transfer of values. Free vector depends only upon its direction and magnitude. It does not depend upon its position in space. So, like this vector is in this direction, so I can move it in this direction in however way. In this direction, in however way. That's a free vector. Understood? Second, localized vector. A vector which can only be shifted along its line of action is called localized vector. I can only, yeah, actually I've उल्टा बता दिया मैंने. This vector can be shifted in any manner, but what is fixed is its length. The length. This length is fixed, and the direction along this length is fixed. And it can be moved in any direction. The localized vector is the vector that can only be moved in its only direction, and its magnitude and direction as per the magnitude is fixed as well. Third vector, like vectors. The two vectors of same direction are called like vectors, irrespective of their magnitude. Let's say this vector, this is the vector A, and this is the vector B. They are going to the same direction, but their magnitude is different. Magnitude of A vector is greater than B, but the directions are equal, so they will be called as like vectors. Unlike vectors, the vectors having opposite line of action are called unlike vectors. So if I say this is A vector, if this is B vector, then A and B are unlike vectors because they are having opposite direction. Okay. Next type is equal vectors. If there is any doubt at any point of time, please interrupt and stop me and ask it out. Equal vectors. Equal vector having same direction, same magnitude. Same direction, same magnitude, both of the things. Equality of vectors. Okay, let's now discuss about zero vector. Zero magnitude, zero direction. Actually a point. No magnitude, no direction. ठीक है? Direction cannot be defined. The magnitude even cannot be defined. It's a dimensionless quantity. Negative vectors. Let's say there is a vector A. So if I have to find out the negative vector, the magnitude will be the same. The magnitude will be the same, but what will change is the direction. What will change is the direction. Magnitude is same. Clear? Any doubts?
No, sir.
Yes, any doubt, Gurucharan?
No, sir. No, sir.
No. Okay. So when we talk about parallel vectors, they are also known as collinear vectors here. Actually, those vectors having same direction. So two or more vectors are known as collinear vectors if they are parallel to a given straight line. If they are having same direction, they can have different vectors. They are somewhat like the like vectors. Parallel vectors, they can have different magnitude. And the property is that one vector can be represented as the multiple of another vector, and this is scalar. So let me write like a vector is say 2i cap plus 2j cap. B vector can be written as 2 into I plus j cap. I should have written it differently. Let's say the B vector is I cap plus j cap. So here A vector can be written as 2 into B vector. So 2 is the scalar here. Basically, the direction of both is the same and the magnitude is different. Clear? Any doubt?
No, sir.
This is an example. Coplanar vectors. So simple, co means same, planar means planes. Coplanar vectors. Vectors lying on same planes are known as coplanar vectors. Simple. So if this is like a Cartesian plane, so if a vector is lying in xy plane only, xy plane is what? This plane, excluding the z component, then they are coplanar vectors. I should draw a nice drawing for you to understand. This is the x-axis, y-axis, z-axis. Exclude it. The vector is lying in xy and another vector is also lying in xy plane. So these two vectors lying on the same plane are known as coplanar vectors. Remember 2i plus 2j cap, I cap plus 2j cap. These two vectors are coplanar vectors because they are lying on xy plane. Clear? Any doubts?
No, sir.
Position vector, we have already discussed. Position vector that there is an origin and there is a point. So the vector OP is position vector because OP vector is defining its position as per the origin. But when we discuss about 2 points and then draw a vector, then that vector will be known as displacement vector. Let's call that this is xy plane. This is a point, this is another point. If we are taking a vector from a point to another point, that we are displacing from a point to another point, then the vector is known as displacement vector. So if a particle is displaced from A to B, then displacement AB is a vector, and AB is called the displacement vector of that particle. We have talked about it earlier that the OA is also a vector, the OB is also going to be a vector. This point here is O. So AB vector will be given by OB minus OA. Clear? Any doubts?
No, sir.
Okay. Great. So there are some direct results that I'm now going to write. Please read, because they are like directly taken from the previous year questions. So it can help you in solving these questions in a faster way. There's a triangle and its medians are there. Let me draw the medians in terms of factors only. A, B, C, D, E, F, G. Okay. So here, thing to understand is that A, F, C, E, and D, B are the medians. Actually, I have not followed the convention while writing this. A, D, B, E, and C, F. This is most generally used. So here, A, D, B, E, and C, F are the medians. So if it is known to you, then the direct result is that the vector AD plus vector BE plus vector CF sum is going to be a zero vector, always and every time. AD plus BE plus CF is always zero. That is the result. Just take a note. Any difficulty in understanding this?
No, sir.
Okay. We have talked about the addition of vectors. There is no specific subtraction of vectors. Okay. There is no subtraction of factors. It's addition only. A vector minus B vector will be solved as A vector plus minus of B vector. We know minus of B vectors can be found out. Like if say B vector is this, then what will be its minus? Simply, what will be its minus? We'll draw the arrow here. Change the direction. that will be minus v1, and add it. Add it with the a vector. Let's say a vector is this. Okay, then a b vector will be a minus b vector will be, we are adding these two vectors. So the vector in its opposite cyclic direction. This will be the addition of both of these two vectors. Clear? Any doubts? Yes or no? Okay. So let's now understand the addition of vectors a little more deeply. If let us say you have added two vectors, how do we add two vectors? If given vectors are in form of a vector is x, even I cap plus a2 j cap plus a3 a cap. If b vector is b1 I cap plus b2 j cap plus b3 k cap. So a plus b vector okay, so a plus b vector, a vector plus b vector, we find it out by simply a1 plus b1 I cap, a2 plus b2 j cap, a3 plus b3 k cap. Let's take some examples. So, for example, vector C is 2 I cap plus 3 k cap. Vector D is minus of I cap minus of 5 k cap minus of 5 j cap plus 8 k cap. You have to find out C plus D. How will you find out? Simply add I caps with I caps. 2 minus 1 makes it plus 1 I cap. 0 j minus 5 j minus 5j plus 3 plus 8 k cap plus 11 k cap. So simple. It is simple. Any doubts?
No, sir.
Okay. So this is how we have find it out the addition of vectors. But what if someone asks about the magnitude of the resultant vector? There's a vector like this. There's a vector like this. There's another vector b, and then there is its addition vector. You have to find out the magnitude of a plus b vector. You do not know about the a vector and b vector completely. You only know their magnitude and the angle between them. This angle you know. And you know about the magnitude of a and b. Now how are you going to find out the magnitude of a plus b? It's simple. We know that a vector plus b vector magnitude will be given by A vector's magnitude whole square plus B vector magnitude whole square plus 2 A vector into B vector magnitude into cosine of theta. And I'm going to explain and prove this formula, how this formula is derived, later when we have discussed scalar product of two vectors. First, you just need to remember here, memorize this formula. That the magnitude of A vector plus B vector will be given by this form. When you have the magnitude of A vector, B vector, and the angle between them. Any doubts?
No, sir.
What if we have to find out A vector minus B vector's magnitude? It will be given by A vector square plus B vector square plus, sorry, minus 2 A vector magnitude into B vector magnitude into cosine of theta. And remember, theta is the acute angle here. We are always going to take theta acute angle. Cos theta will always be positive. But we have applied the negative sign here. Why? I'll explain later. But just memorize here. If we add the magnitude of A plus B vector plus the magnitude of A vector minus B vector, it will come out as their square. It will come out as A square plus B square has added, and this plus 2ab minus 2ab, this term has cancelled each other. So twice of magnitude of A plus magnitude of B. This is self-explanatory. We have taken their square and then added A square plus A square, 2A square, B square plus B square, 2B square. And the remaining term cancels each other. Clear? Any doubts?
No, sir.
Okay. So we have talked about the addition of factors, and we have talked about the magnitude of the addition of the vector. Now let's discuss about the multiplication of factors. Product, that we call it. So there are two kinds of products of vectors. One in which the product is a scalar quantity. And that kind of product we call it as scalar product. Another multiplication in which the product comes out as a vector quantity. So we call that product as vector product. So the unique feature is the product, the resultant that is coming out. If the result is a scalar, then that product is known as scalar product. It is also known as dot product. And this is also known as cross product. Let's discuss them one by one. The thing here to consider is that the result, the product given is scalar quantity, and the product here produced is vector quantity. First, let's discuss about the scalar product or dot product. So dot product, we call dot product because we represent it by writing a dot between these two vectors. So it will be simply given by a vector magnitude into b vector magnitude to cosine of theta. Theta is the angle between a vector and b vector. So a vector is this, b vector is this, a vector is this, and b vector is this. The angle between is theta. This is how we find out scalar product. Let's take an example. A vector is, let me see, look for an example. Wait, let me find out an example. Let me make an example. The vector is 2i cap plus 3j cap plus 5k cap. B vector is 2i cap plus 3j cap minus of 5k cap. You have to find A dot B. Let's do the solution. So A dot B, simply A vector's magnitude, B vector's magnitude, cosine of theta. I forgot, right? Theta. Theta is 180 degrees. Okay. So the magnitude of A vector will be given by 2 square, that is 4, plus 3 square, that is 9, plus 5 square, that is 25, into B vector magnitude. It will be given by x square, that is 4 plus 3 square, 9, plus minus 5 whole square, that is also 25, into cosine of 180 degrees. So this comes out as 13 plus 25, 38, into square root of 38, into cosine of 180, which is minus of 1. 38 into 38 makes it 38, into minus of 1. So that becomes our scalar product. That is our answer, minus 38. Clear? 180 degrees angle means they are unlike vectors. Unlike vectors. Sorry, I have done a mistake here. While constructing this question, I have done a mistake here. There was no requirement for you to find out, for you to have theta. It can be just found out by A dot B. 2 into 2, 4 I cap. 3 into 3, 9 Z cap. Plus 5 into minus 5. That makes it as minus 25k cap. That is the answer. I'll explain it later. Let me explain this to you first. 2 I cap dot 3 j cap. These are two vectors. Now understand simply that I cap, when will get dotted multiplied with j cap, what is its magnitude? It's 2. Its magnitude 3. Okay. 2 into 3. What is the angle between I cap and j cap? I cap is this, j cap is this, 90 degrees, like, right? Cosine of 90. What is cosine of 90? 0. Getting it? So, from here, we can draw another formula for the dot product. If a vector is given as ai cap plus bj cap plus ck cap, even b1, c1, let me call it. And b vector is given as a2 I cap plus b2 j cap plus c2 k cap. Now understand very keenly then that when a1 I cap will get multiplied with a2 I cap, then a1 into a2, that is the magnitude. I cap into I cap. I cap, sorry, I cap dot I cap. Its magnitude is a1, a2. Angle between I cap and the I cap is 0 degree. Cosine of 0 is 1. So a1, a2 is the answer. Plus a1, b2. a1, b2, okay. The angle into cosine of the angle between I and z, that is 90 degree into z. Plus, so similarly, all other dot products between I and j or k will be 0. So what we will be considering is only the product of I cap quantity with I cap. So the result comes out as A1, A2, B1, B2 plus C1, C2. And there are no I's and Z's or K's cap are left. Only the scalar quantities. So here we may write A dot B as 2 into 2, 4, 3 into 3, 9, 5 plus 5 into minus 5, minus 25. The answer comes out as 13 minus 25. That makes it as minus 12 as our answer. And theta was not given here, directly vectors. So these are two formulas by which we can find out the scalar product. Actually, this is the main formula. And that is its application. Two vectors are given. Any questions? Yes or no?
No, sir.
Yeah. So from here, we can draw some cases. If theta is 90 degrees, if vectors are perpendicular, then their dot product will be 0 because cos 90 is 0. If vectors are parallel, then the dot product will be the multiple only, the multiple of the magnitude only, because cos 0 is 1. Now, what's most important is this property, multiple uses, multiple uses. From here, we can draw more properties. That if two vectors are perpendicular, then the dot product is 0. So I cap dot I cap is perpendicular to j cap, right? So their dot product will also be 0. Similarly, for j cap and k cap, 0. I cap and k cap, their dot product will also be 0. From here, we have written that if there are two vectors given as a1 I cap plus b1 j cap plus c1 k cap, b vector is given as a2 I cap plus b2 j cap plus c2 k cap, So the dot product will be given by A1 A2 plus B1 B2 C1 C2, because all other multiples A1 B2 I dot J will become 0. That's why. Is that clear now?
Yes, sir.
Scalar product also follows the commutative property, that is A dot B is equivalent to B dot A. There's no problem in that. It also follows the commutative associativity property, may be written as A dot B plus A dot C. Any doubt in understanding these two properties?
Yes.
No, sir.
This is very important. Please keep this thing in mind, that cos 90 is 0. So that's why the dot product of two perpendicular vectors will always be 0. And from here, the angle between two vectors can also be find it out. If we know the dot product, if we know their magnitudes. Let's take an example of this. We have to find the angle between three I cap plus two j cap minus six k cap and 4 I cap minus 3 j cap plus k cap. Okay, so let's find out, let's call this vector as A and let's call this vector as B. Let's find out the dot product first. The dot product will be 3 into 4, 12 plus 2 into plus minus 3, that makes it minus 6, minus 6 into plus 1. The dot product is 0. We know cos theta is dot product divided by its magnitude. So we will not even bother to find out the magnitude because the numerator has become 0. And we know 0 divided by anything, we make it as 0 only. So when is cos 0? When vectors are perpendicular, when theta is 90 degrees. Na, 0 cos theta is equals to 0 can be written as cos 90 degrees. Cos cancel, theta is 90 degrees. So the angle between those two vectors is 90. Clear? Any doubts?
No, sir.
Okay. Now there's a very interesting question coming up. Question is, there are two forces, F1 3 I cap minus 2 j cap plus k cap. There's another force, I cap plus 3 j cap minus 5k. These two forces are acting on a particle or move it from a position A to position B. Okay. We have to find out the work done. We have to find the work done. If the position vector of A is minus 2i plus 5k cap, the position vector of B is 3i cap minus 7k minus 7 j cap plus 2k cap. Now we have to find out the work done. Do you know the formula of work done? Class 10th. Do anyone remember the formula of work done?
Force into displacement.
Yes. Work done is the scalar product of force and the displacement. First, let's find out the net force on the particle. The net force on the particle is F1 plus F2. So I'll simply add them. 3i plus I cap become 4i cap. Minus 2j cap plus 3j cap becomes plus j cap. Plus k cap minus 5k cap becomes minus of 4k cap. Dot product with the displacement. So let's find out the position vector of the displacement from A to B. So 3i we'll find out the AB vector this time. So how we will find out the AB vector? See, for finding out the net force, we have added the net force is F1 plus F2. Now the displacement will not be added. How we will find out the AB vector? Can anyone tell me? Anyone? We'll subtract B vector from A vector. Actually, OB vector from OA vector. Right? The OB vector is 3i cap minus 7j cap plus 2k cap minus this vector. So minus minus plus 2i cap minus 5k cap. The result is 3i plus 2i, 5i, minus 7 plus 0, so minus 7z, plus 2k minus 5k minus 3k. Dot product. So all will get multiplied with respective I caps. So 4 into 5, 20 plus 1 into minus 7, minus 7 plus minus 4 into minus 3 plus 12. 20, 12 is 32 minus 7 becomes 25 joules is the work done. Okay, 25 units actually. We don't know about the unit. 25 unit is the work done. Any doubts? Any doubts?
No, sir.
No, sir.
Okay. Displacement was AB vector going from A to B. Today is wedding season, right? There's so much weddings going on around. Is that so there also?
Yes, sir.
Okay. I can hear a lot of music going around and I'm craving. I have an invitation to go somewhere. So I'll go just after the class ends. Exciting. Exam. So there are vectors u, v, w, u vector plus v vector plus w vector is given as 0. Is given as 0 vector. 0 vector is basically 0i plus 0j plus 0k. Okay. If the magnitude of u vector is 3, the magnitude of v vector is 4, the magnitude of w vector is 5, then we have to find out u dot v plus v dot w plus w dot. This is what we need to find out. Okay, so let me paint. Okay. So what is given? Wait a minute. What is given is u plus v plus w is equals to 0. And I can remember something. I can remember an algebraic identity here. And I'm going to use it. See how u plus v plus w vector is given as equal to 0. I'll square on both sides. So 0 square is 0. Its square is u vector square. U vector square plus v vector square plus w vector square plus 2 u vector dot v plus 2 v vector dot v dot w, sorry, 2 w vector dot u vector. Okay, now it's one thing to understand. What is u vector square? What is a vector square? It is the dot product. Okay, we know if there is a vector getting getting scalar product with itself only, the theta is 0. So it's actually the magnitude of a magnitude of another vector cos of 0 degree, which is 1, which becomes the magnitude's whole square. So a vector's square is actually the magnitude square. It is just the same. That's one concept you can take a note of. So here u vector's magnitude, which is with us 3, 9. V vector magnitude is 4 whole square, 4 square, 16. W, 25 plus 2 u v plus vw plus wu is equals to 0. We have to find out this only, right? So let's keep it in the left hand side. And bring the remaining on the right hand side. So first let's find the sum. 16, 25, 9 and 16 is 25, 25, 25 makes it as 50. So plus 50 goes to the right hand side, makes it minus 50. UV plus VW plus WU minus 50 by 2 minus 25 is our answer. Understand how we have approached this question. Let's take any doubts?
No, sir.
Let's take an example. The position vectors of P and Q are given as A, B, R. Okay, so P and Q, R is a point. This is this vector PQ. R is a point on PQ line. Okay, let's draw from origin OP vector. OP vector is given. And what is given? OQ vector is given. OP vector is given as A. OQ vector is given as B. R is a point on PQ such that PR is equals to 5 of PQ. PR is equals to 5 times of PQ. Okay, for that we need to understand the sectional formula for vectors. It's good that we have came across this formula so that we are not going to leave this topic. So section formula. We know section formula, we discuss it for two kinds of things, inner division or external division. First, let's discuss about the first case, inner division. So there's a vector. Give me a moment. Coming back in a minute. Okay, yes. So yeah, sectional formula. The section formula or sectional formula. Actually, we are discussing generally what happens that there are 2 points, A point and there's another point, B point. So this is the original points, but there is a point that we discuss about. Let's call this as point as P, and we call that this P point is dividing AB internally in some ratio. Let's say that in ratio M is to N. What is M and N? Actually, AP divided by PB. This is the ratio M is to N. Okay. Now we know about OA vector. We know the position vector of A vector and B vector. These are actually A and B. And we have to find out the vector of this position, this point P. So this comes out as M A vector plus N B vector divided by M plus N. As simple as that. For internal division, this is the form. When we talk about external division is when there's like a point A vector from A point to another point B. If we extend this line, there exists a point C. There exists a point, let's write C. or I should write P only. The position vector of A is A vector, the position vector of point B is B vector, the position vector for P is P vector.